Hello everyone, welcome to another Kinetic tutoring video. Today we're looking at another energy problem, and let's just get straight into the prompt. It reads, in the figure, a block of mass m is moving along the horizontal frictionless surface with a speed of 5.7 meters per second. The slope is 11 degrees and the coefficient of kinetic friction between the block and the incline is 0.260. How far does the block travel up the incline? Alright guys, so let's take a look at the energy at this point. We're going to call this point 1, point 2, and then we have point 3. Point 3 is where the block is going to stop and its maximum height. So, at point 1 we have this kinetic energy translational. The block is just sliding to the right, and there's and when we take a look at point 2, you'll realize that since there's no friction, it's going to be the exact same. And the reason I illustrated these 2 points is just to get my point across that between 1 and 2 not much happens. Here we just have the kinetic energy, and here the kinetic energy is preserved because there's no work done. So we can really just start from here, point 2 to point 3. So we're going to call this point that we previously referred to as point 3, point 2, and we're going to call this point here we're going to call what we previously called point 2, point 1, and point 3, point 2. So from here, we're going to find out the different energies on top of here, or to find out the different energies at the bottom of the system and at the top of the system. Here, the block is just going onto the incline, so it's not going to have any potential energy due to gravity because it's just going up, so its height is still going to be 0. It's not going to have any work done by friction because it is just now entering the area where there is friction, so the energy is going to be strictly kinetic. And we know that the kinetic energy equation is just 1/2 mv squared. And due to preservation of energy, we know that the energy at point 1 is going to be equal to the energy at point 2. Now, at point 2, we know that our block has stopped, so there's not going to be any kinetic energy left. It's all going to be transferred into potential energy due to gravity. And we know the equation for this is just going to be mgh, where h is the distance from this height here to the bottom here. And this isn't all though, because we know that there is friction, there is some energy that is dispersed out of the system onto the ramp, and this is going to be accumulated for using work. And we know that work is simply force times distance, and when we're talking about work done by friction, we know that the force is just going to be the frictional force. And now keep in mind that this d here is just going to be this distance here from this point all the way up to this point here. Alright, so now that we have that, what I want to do is write h in terms of d. Now, since we know that this angle 11 degrees forms our triangle, we can just say that this is our opposite angle, this is our hypotenuse, and opposite over hypotenuse forms sine. So we'll have sine of 11 degrees times the magnitude of this length, which is just going to be d. So h can be written as d sine theta. So let's rewrite this equation here. We'll have 1/2 mv squared is equal to mg d sine theta plus frictional force times d. Now from here, our final step before we just do our calculations is to find the frictional force. So let's take a look at our block here. As it's going upwards, as it's moving upwards, the frictional force is going in the opposite direction, this way. So We know that friction force is just mu normal force. Our mu has been given to us. Now we just need to find n. We know that our n is simply equal to the vertical component of gravity, and we know our vertical component of gravity is just going to be mg cosine theta. So our frictional force is mu mg cos theta, and then paired with the distance will give us mu mg cosine theta d. So let me erase all of this here. I'm going to erase this top equation so we have more room. And then we're going to rewrite our equation. We'll get 1/2 mv squared is equal to mg d sine theta plus mu mg cos theta d. I'm going to erase this over here. And finally, our last step is just to calculate and solve for our distance d. So let's plug in all the values that we know. Or first actually, we notice here that there is a common m shared between all the terms. So we can cancel this here, which is a good thing because the mass is not mentioned in the equation. But luckily, we just noticed that it does in fact cancel out. So we get 1/2 v squared. We realize that we can factor out a GD from both of these terms. So we get GD sine theta plus mu cos theta. And now from here we can divide both sides by g. We'll get 1/20 v squared is going to be d sine 11 degrees plus mu cosine 11 degrees. From here we're going to do our calculations. I'm going to erase these previous calculations in order to give us some more space. So let me pull out my calculator really quickly. Sine of 11 degrees becomes 0.19. Cosine of 11 degrees are somewhere around 0.98, but then we have to multiply it by mu, which is 0.26, which gives us a value of around 0.26. From here we have a simple equation. You know that our v is 5.7, so our v squared will be 5.7 squared. Let's plug that into our calculator. This gives us a value of 32.5. So from here, we're going to multiply everything out. I'm going to erase this bottom part right here. 32.5 divided by 20 gives you 1.625. We'll just write it as 1.63. 1.63 divided by these two added together gives you 0.45. And finally you get a distance d of 0.036. Sorry, I did that calculation wrong. Let me try that again. 1.63 divided by 0.45. You get a d value of 3.62, and we know that when we're talking about distance, our common unit is meters. So our distance from point A here to point B here is going to be 3.62 meters. I hope this helped. If there's still any confusion, make sure to ask your questions down below in the comments, or if you have any additional questions related to any of these topics, please do let me know. And yeah, that's all I have for you guys today. Make sure to like and subscribe, and stay tuned for more physics tutorials.